Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Loka Seva Gurukulam online classes. And the topic thermal energy. I think all of you are heated now. After eating nicely or walking in the hot sun or by rubbing your hands, etc. Heat is produced. So you get a good amount of energy, right? So that energy which comes by heat is called as thermal energy. So in the thermal energy, we have seen the difference between heat and temperature, right? Heat is a form of energy. The degree of hotness or coldness of a body is measured in temperature. And heat is measured in joules or calories. Temperature is measured in degree Celsius, degree Fahrenheit or Kelvin, is it not? And temperature is measured in a device called thermometer, whereas heat can be measured in calorimeter. So these are some of the differences between heat and temperature. And also in the previous class we have seen different kinds of thermometers. We have also studied about effects of heat. The rise in temperature means when heat is given to a body, its temperature rises. How do you know it? By keeping on thermometer. And change of state means what? When heat is given to, say for example, ice, it melts, it turns into liquid, namely water. And if water is heated strongly, it becomes steam. Is it not? That is what is called a change of state. Similarly, if you remove the heat, steam becomes water, water becomes ice. So that is the effects of heat. And also you have studied about thermal expansion. So when you say expansion, a very interesting phenomenon. So there are actually three types of expansion when heat is given to a body. One is the linear expansion, increase in length, we call it as alpha. And there will be expansion in area, we call it as beta. The coefficient is called beta. And expansion in volume, the coefficient is called gamma. The ratio is 1:2:3. And also we have seen about the construction and working of a bimetallic strip. As the name itself says, bi means what? Two. So combination of two metals, and they are fixed to a point, and that it is heated, there will be variation in expansion. And the properties made use of devices like thermostat, iron box, and refrigerators, and so on. These are all the things you have studied already. Coming to home assignment number 2, I think all of you have prepared answers. Name the factors on which the thermal expansion of a wire depends. Answer is, the thermal expansion of a wire depends upon the rise in temperature. As there is a rise in temperature, the expansion also increases. and secondly, nature of the substance. So it depends on the metals. Different metals will have different thermal expansions, is it not? And also the state of the substance, a solid or liquid or gas. In case of gas, the expansion is state. For example, if you take copper, the molecules are tightly packed, is it not? So the heat is transferred from one particle to another. So these are the factors on which the thermal expansion of wire depends. Second question is, give any two uses of bimetallic strip. It is used in thermostats for heating purpose or cooling purpose. I was just telling you that it is in refrigerators, in iron boxes. Iron box also you might have seen, there will be a sound comes up when the coil, there will be asbestos coil inside, asbestos coil. So when it is, there will be a strip of alloys which is covered by asbestos. So when heat is applied, it gets heated up. When it reaches a maximum temperature, there will be a sound comes up. Means it stops automatically. And how it happens? It is because of the bimetallic strip. There will be two metals of different conductivity. And because of the different conductivity, the expansion also will be different. Okay. Why the heat given at the time of change of state is called latent heat? Because it does not become apparent. We will not see it in the form of rise in temperature. For example, when water is heated, it turns into steam. And once the maximum temperature, say 100 degrees is reached, it remains in the same temperature. So it is not apparent, means the rise in temperature is not apparent. It will be steady there. Similarly, water is cooled, the temperature comes down to 0. Below that, if you cool it, it won't be seen. Therefore, the name is called latent heat. Okay. Next question, fourth one. Why does a bimetallic strip bend on heating? Due to different expansivity. Expansivity means change in length. Of course, if you take a metal sheet, it will be area also. So, different expansivity of two metals, a bimetallic strip bends on heating. For example, other day we gave an example of steel and aluminum, right? So, the aluminum has more conductivity or expansivity. So, it bends faster than the other metal what you use. So, that is the reason. Okay. Now, coming to today's topic, here is an activity to show the expansion in liquids. Here, a transparent bottle, like injection bottle is taken. This is the injection bottle. Okay, it is filled with water to the brim. So water is filled up. A small hole is made in its cork. So there will be a cork. This is a cork. There will be a hole made in it. And a thin transparent plastic pipe like the ball pen refill. It should be transparent. Why should you take transparent? What do you mean transparent bodies? Transparent means you can see from one side to other. clearly. It is said that our behavior should be transparent. As you behave behind, same way you must behave outside also. There should be transparency. Even if you are given with 1 crore rupee in hand, or a check of say 10 lakhs or 11 lakhs in your hand, you must be very transparent. Means your business or your dealings of the money should be honest. Okay, honesty is the best policy. I hope you understood what I am telling. Suppose your father gives say 1000 rupees to bring some articles from the market. You should be very honest. Okay, whatever the items list is given, you want to make purchases and bring it correctly and give the money also correctly. You must be honest. Okay, your country also we have a lot of honest people. That is why there will be some progress in the nation. But at the same time there are so many dishonest also, so that all the public property, public money is misused. That is a danger for the nation. Okay, now coming to the point here. So plastic pipe. So when you say plastic pipe, it should be transparent. That is the meaning. So plastic pipe is introduced into the cork, is inserted in so that the lower end of the pipe dips in water. So this is the lower end, is dipped in water, and water rises in the pipe up to a certain height. So when it dipped in water, it comes to, let us suppose it comes to a height called A. Followed? Now this bottle is to be heated. When this bottle is heated by the help of a Bunsen burner or a spirit lamp, what happens? Water level, instead of going up, it comes down first. That is an interesting point you can note. It comes down to B and then rises to C. That is a very special, peculiar property of water. Okay, and what is the special property called? That is called anomalous expansion of water. Anomalous expansion of water. It means that when water is heated from 0 to 4 degrees Celsius, instead of expansion it cools down, and similarly if it is cooled from 4 to 0, it expands. So this peculiar property of water is called as anomalous expansion of water, and this phenomenon is used in cold regions like Arctic and Antarctic regions, where the ice will be below 0 degrees Celsius, and there will be fishes and all below that icebergs. They are very, very safe there, because the top they have ice layers, below that there will be water, and in that water there will be fishes, because man cannot enter that place. Whatever the man touches or interferes, there will be some nuisance, especially for the plants, animals, birds and so on. Not all. Of course, there are so many good people also who will protect and encourage. That's also there. But there are some who will be troubling. So if we are not supposed to trouble. or you are not supposed to give any problem to the birds or animals or plants, etc. Instead of that, we have to encourage them. Okay, so you might have heard about lot of fishes, beautiful fishes, which play with men. Can you name them? Some of the fishes, they are used in aquariums also. They preserve it, is it not? So there are a lot of intimacy between men and animals, men and birds, men and plants also, gardens and so on. When you say men, it includes women also. So we should also love nature. And if you love nature, nature also loves us. So they also will develop. Okay. So what do you get from this? When water is heated, it contracts first and then it expands. That is in the case of expansion in liquids. Okay. Then what about gases? Similarly, expansion of gases can be seen by taking a thin capillary tube which is having a mercury level inside. One of the tube is sealed, and when it is heated, there will be a change you can observe. For example, in the experiment what you have seen just now, a thin walled narrow bored glass tube is taken. Glass tube, you must know difference between tube and the rod. Rod means there is no hole inside. Tube means there will be a hole, or it is opened on both sides, right? And a drop of mercury. How does the water level, mercury level will be there? Suppose this is a tube, this will have a convex surface. In case of mercury, the surface will be convex. Suppose you take water, what happens? If this is water, the surface will be concave. Note the difference. The meniscus, you use the word meniscus, this level is called as meniscus. So mercury meniscus will be convex in nature and water meniscus will be in concave in nature. Why it is so? That is, density of mercury is very high, and of course you are going to study later in the higher classes the point called surface tension acts. Okay, so here a drop of mercury is entrapped in it, means it is trapped inside. The one end of the tube is heated, so you have to heat it. By pressing it on a hard surface, this end is sealed. So that is how the sealing is made. Okay, because it is a glass material, the other end should be open and one end should be sealed. Let the tube cool to normal temperature. Now the tube is held vertically. In this way we have entrapped a column of air between a drop and sealed end of the pipe. So there will be air column in between this. So what do you observe? So mercury is there inside a tube, right? So this is a mercury level and this is a tube, this is a sealed one. Okay. Now even if you warm the air column by holding it in our hand, we can see the drop of mercury shifting its position. See, in class also, if the class is very noisy, what the teacher does, she gives a warning. Hey, students, keep quiet. When warning is given, most of the boys and girls will become silent. In high school, all will become silent. That is because a kind of warming takes place. In other schools, they have to use some scale also. Otherwise, they won't take seriously. So that is called as a warming business. Here also, if you have this, if you hold it in your hand, because of the warming, the drop of mercury shifts its position. We observe that air column moves up and down for small rise in temperature. So depending on the rise in temperature, how do you get rise in temperature? Just like this. Suppose this is a tube having mercury, and below that mercury level there will be air, gas. So if you hold like this, because of the heat of these hands, the gases expand, and that is why, that is one expansion we can see in case of gases. And in gases, the molecules of air will be in large distances. They are at large distances. Whereas in liquids, they are little nearer. In solids, they are very, very close. Okay. So that is how it affects in case of gases. Now let us see what are the uses of thermal expansion. The first one that we already seen it in thermometers. The property of thermal expansion is used. What is there inside in thermometers? We have, in many cases it is mercury, or in some cases there will be alcohol also, red color. So what happens when it comes in contact with any body, maybe human bodies or any boiling water or any other substance? The level increases. In the case of mercury, the rise will be slow and steady. Is it not? And because of the shining luster of the mercury, can see it. So why this is an example or application of thermal expansion. It means when heat is given, it expands. Similarly, a tightly closed metallic cap of a bottle may be opened by using thermal expansion. So this is a bottle. There is a cap for it. There is a cap. And it is difficult to remove the cap. So what you have to do? Keep the bottle inside a boiling water. So if it is kept in a hot water, the lid becomes loose because of the expansion. The lid gets expanded. So the cap on heating expands, becomes loose, and it can be, the lid can be opened easily. Okay, that is another application of thermal expansion. Coming to the next important expansion, we heard about Tonga. I think many of you have seen Tonga, or you have seen the bullock carts in your villages. Is it not? So this is one, the wheel of a bullock cart or a tonga, and you have seen there will be what is called as a metallic ring, and the wheel is covered by this metallic ring, and what they do is they will take a little lesser radius, heat it strongly and fix it on the wheel. And there what happens, because of expansion, even though the radius is small, when it is fitted to that wheel, because of expansion, it tightly fixes. You might have seen how the bullock carts, they fix up the metallic sheet at the outer area, is it not? So that is because of the expansion of the steel or iron, whatever material is there. So that is an example. So it may be for horse cart or it may be for bullock cart. Next is thermostats, about which I already discussed now. When it is for heating or cooling, the bimetallic strips that is used, automatically switches off. You might have heard in a fridge, refrigerators or an iron box, etc. the sound coming, tuck. Tuck means it is sufficiently heated. Why it happens like that? That is because of a bimetallic strip inside it. The temperature rises. Rises means heating takes place. And sometimes cooling. Then the temperature falls. That is because of the expansion in the case of bimetallic strip. Okay. So this is a bimetallic strip. And here there will be two metals. And this is heated by electrical circuit from external source. When it is heated, there will be difference in the expansion. Because of the difference in expansion, the one of the metal expand more than the other. So it disconnects the connection, and hence the device is made safe. So that is another application of thermal expansion. Also you have heard about gaps left in the joints of a railway track. In railway track also, I think all of you have travelled on trains, right? And what is the difference between the motor vehicle and the train? Train moves on the railings. It is made up of steel, and between two railings there will be gap. There will be gap between the two railings. Why should be gap should be given? Because when the train moves on the railings, there will be friction. Because of friction, there will be expansion. Heat is developed which expands the metal. And when there is a expansion in the metal, the train railings gets bulged like this. You might have heard about so many accidents taking place where the train gets the railings, when the train is moving on the railings, because of there will be a lot of, you might have heard about so many accidents taking place. Derailing we call it. And the derailing take place. So if they are kept in gaps between, what happens? Even if it expands, there will be no change. Or in other words, the wheels of the train move smoothly on the railings. If the gap is not left, what happens? There will be bulging, or the railings get enlarged, by which when the train moves on that, there will be derailing taking place. Okay. So there will be compulsory, there will leave gaps for a certain distance. And you might have heard about bridges. In bridges also they leave gaps. If you see a bridge in near Bijapur, one of the biggest, longest bridges in Karnataka for the Krishna river. Some 1 point something kilometers, 3 kilometers, about 3 kilometers. One of the biggest, longest bridges. Or see, you might have seen any bridges for that matter. There will be concrete roads will be there, and between certain distance there will be some gaps. They leave some gaps, and that gaps are left because they are called as girders. Girders in iron bridges, because due to heat of the summer, or because due to the friction of the tires which move on the bridges, the steel material gets expanded, and that gives some nuisance or some problem for the vehicles to move out. And that's why, if you know this principle that solids expand on heating, they use what is called as girders. And by using girders on iron bridges, that accidents or the vehicles being in trouble can be avoided. And one more application or use of the thermal expansion is, you are not supposed to pour water directly or pour hot tea on a glass tumbler. For steam tumbler, okay, because expansion is very, very negligible. But if case of glass, suppose you pour hot water or very hot tea, suddenly it expands and the tumbler breaks up. So what you have to do for that? You have to keep a metallic spoon first. Then you have to add hot tea to be poured in it. So the direct expansion is controlled. And one more example you can see, or you have seen already. When a hot tubelet is there, a bulb is there, if you put one small drop of water, of course don't experiment it, because you are losing tubelet or light. When it is hot, just sprinkle one drop of water, it cracks or it breaks because of the thermal expansion again. Because the tubelet or the bulb, even the bottle or the here it is glass tumbler, they get expanded suddenly. And suppose you pour water or sprinkle water, the hot substance will become cool suddenly, and hence there will be breaking. So these are some of the interesting experiments or interesting applications of expansion of substances, thermal expansion on heating. Now we will come to one more interesting point, that is called as specific heat or specific thermal capacity of a material, also called as specific heat. It is usually different, usually written by the symbol S. When two bodies at different temperatures are kept in contact, heat is transferred from the hot body to the cold body till both of them acquire the same temperature. The two bodies then are called in thermal equilibrium. One simple example you might have seen in home. If you are given the very hot water, what do? You add some cold water. So what happens? By adding cold water to the hot water, the temperature of hot water becomes less. Temperature of cold water becomes more. So by the process, by the exchange of these two, there will be what is called a thermal equilibrium. Equilibrium means balance. So here what happens? Hot body loses temperature, cold body gains temperature. Is it not? So heat lost by hot body is equal to heat gained by cold body, provided we assure that there is no loss of heat due to surroundings. Because if the hot substance, the surroundings is very hot, it may also influence, or if it is cold also it may influence. So let us suppose that there is no loss in the surroundings, then heat lost by one hot body is equal to heat gained by cold body. Okay. So heat is transferred from a hot body to a cold body is directly proportional to their temperature difference. So let us take the temperature difference as delta theta. Theta stands for temperature. Delta means small temperature. Q is quantity of heat. So quantity of heat given to a substance depends on temperature. So is directly proportional to temperature. And if the quantity also depends upon mass. For example, if you take half liter of water and heat it, and if you take 1 liter of water and heat it, compare. The 1 liter require more time because the mass is more. So these are the two factors. And also one more thing you must note, that is a speciality for every body, and that is what is called as specific heat. So combining these two, we get quantity of heat given to a body depends upon mass and variation in temperature, or a small change in temperature. Okay. So the formula will be Q is equal to ms into delta theta, where m is the mass of the body. And what is S? S is a constant of proportionality called as specific heat. For every body will have its own specific heat, right? And delta theta means variation is a small quantity of heat given to a body. Okay, so there is a very important formula you should note, and you should be able to work out problem also. So specific heat capacity of a material is defined as the amount of heat in joules required to raise the temperature of 1 kg of mass of that material through 1 Kelvin temperature. So this is what is called as specific heat. So 1 kg of mass, it is a MKS unit or System International. 1 kg of mass to raise the temperature by 1 Kelvin. That quantity of heat is called as specific heat. And just now we have seen it denoted by a symbol called S. And unit is J kg to the power of minus 1, K to the power of minus 1. K means Kelvin, kg means kilograms, J means joule. How do you got it? The formula is Q is equal to ms delta theta. In this formula, if you want S is equal to Q by m delta theta. So Q is quantity of heat, joules, by m is mass, kg to the power of, that is why minus 1, and theta, delta theta is equal to k to the power of minus 1 measured in kelvins. So this is the formula for specific heat. So specific heat means amount of heat required to raise the temperature of 1 kilogram mass of the substance by 1 Kelvin. Okay. So that is the formula. Here is a list of the specific heats of different substances at a temperature of 20 degrees Celsius. Means how many Kelvin? It will be 273 plus 20, 293 Kelvin. So, because below that we cannot find out correctly, there should be some temperature. Okay. So, aluminum, its specific heat is 875 joules, kg to the power of -1, Kelvin to the power of -1, or 0.29 calories. Okay. Copper 380 joules per kg and per Kelvin raise, or in calories 0.091. I think you remember what we were told last time. 1 calorie is equal to about 4.2 joules. 4.2 joules. So if you multiply by 4.2, you get this. And cast iron 500 joules, 0.119. Wrought iron 483 joules, or 0.115 calories. And it is about liquids, some liquids. And in case of liquids, the specific heat is less, that is what you can observe. Ethyl alcohol, also called as ethanol, it is about 2.436 joules per kg per Kelvin, and it is 0.58 calories. Methyl alcohol, called methanol, 2.562 or 0.61 calories. Benzene 1.680 or 0.4. Ethene, called as ethylene, formula is C2H4. This is C6H6. This is CH3OH, and this is C2H5OH. It's also called spirit. So these are some of the substances and specific heat values. Continuing that, steel is 470 joules or 0.112 calories. Lead is 130 joules per kg per Kelvin or 0.031 calories. Brass is 396, 0.092 calories. Ice is 2100. See, ice has a maximum specific heat, and its calorie in terms of calories 0.502. And similarly, glycerine 2.478 joules per kg per Kelvin, and in calories 0.59. Mercury 0.140 is very less. Turpentine 1.800, water 4.200. So that is the specific heat of different substances at 20 degrees Celsius temperature, right? And let us see some homework. When solid ice at 0 degrees Celsius is heated, its temperature A rises, B falls, C does not change until whole of it melts. D first rises, then falls back to 0 degrees Celsius. So one of the four answer is correct, but fill it up here. Second question, equal heat is given to 3 pieces of copper A, B and C having masses in the ratio 1:2:3. The rise in temperature will be in the order of, you must tell one of the four answers. Okay, will come prepared, write answers for all these. Okay, and one more question, the expansivity is maximum in solids, liquids or gases. Expansivity means expansion due to length, linear expansion, what you call. that is in solids. In case of liquids or gases, which is maximum, you must tell. Then latent heat of evaporation is measured in terms of joules, joules per Kelvin, joules per kg. You must tell the unit of that latent heat of evaporation. As you know, there are two latent heats. One is latent heat of fusion of ice. Another is latent heat of vaporization or latent heat of evaporation. Okay. So come prepared for that. Thank you.